For this video, we're going to look at the brake physics worksheet that we had for homework. That's this guy right here. Now I'm going to do this one a little bit differently. We've got a lot of stuff to go over, and it's going to be quite long by the time we get it all done. So what I'm going to do is I'm going to do this video in sections, and each section is going to be one of the questions. So we're going to do both sides of it. We'll do the imperial side and we'll do the metric side. But if you are looking for just the answer, you just want to check your work, what you can do is for every question I'm going to put in a black title card. So just skip forward to the cards. If you're doing this along with the video, what the cards will do is they'll identify which question we're on, and then you can kind of pause the video, do the question, and then play it. We're going to go through it step by step for each one. So what I did here is, because I want to do the math and show you the steps, I actually took one of these sheets and I just, it's a little cheesy, but I cut it all up, right? So what we're going to do is I'll have my working pad, and then we'll have a reference for exactly what we're dealing with here. So the first thing that we're going to look at is, this is on the imperial side, and it's the chart of our vehicle specifications, right? So we got a component side and a measurement side. So we've got the brake pedal to fulcrum, we've got the output to fulcrum, so this is everything we need to calculate our mechanical advantage. We've got a master cylinder piston diameter, a brake caliper piston diameter, and a wheel cylinder piston diameter. And of course we're going to be using our mechanical advantage formula. We're also going to be using Pascal's law. So you can do this whatever way you want to do it, but the way that I'm going to do it is starting with this chart. I'm going to find the numbers that we actually need to do the calculation. So if we remember mechanical advantage formula, mechanical advantage is EA over LA, where EA is the length of the effort arm and LA is the length of the load arm. And then we're also going to need Pascal's law, where we're going to be concerned with force, pressure, and area. So here, with mechanical advantage, once we know the input force, we can calculate the output force, which will give us our force component. We won't know the pressure, we won't be able to calculate the pressure until we know the areas. And here we have 3 diameters, which of course we're going to have to convert. So what I'm going to do is I'm going to figure out the mechanical advantage based on this, and I'm going to figure out the area to all 3s. And I'm just going to fill those values in right on the chart so we have it as a quick reference. So first, let's move this up here. Let's worry about that mechanical advantage. So we know it's EA over LA, right? Length of effort divided by length of load. We know that the effort is our input and the load is our output. So if we go back to our little chart here, pedal to fulcrum, output to fulcrum, this is going to be our effort. This is going to be our load. So if we fill our values in, we can say mechanical advantage is 12 divided by 4.75. Get the calculator back in. 12 divided by 4.75 gives us 2.5263 157. So I'm going to call this 2.53 to 1. Right? And then I'm just going to fill that in on our chart here. So I'm just going to say mechanical advantage equals 2.53 to 1. Then I got that as a reference for when I'm doing my actual math. Next thing we're going to look at is the master cylinder. We need to know the area of the piston. Set that away for a second. So I'm just going to make a little ladle healer. Master cylinder, piston area. Our area is going to be pi r squared, right? And we have a diameter here of 1.25. So we're just going to divide that by 2 to get the radius. And so 1.25 divided by 2 gives us a radius of 0.625. So area equals 3.14. That's as far as we need to go with that. Times 0.625 times 0.625. So 3.14 times 0.625 times 0.625 equals 1.2265625. So we're going to call that 1.23. Square inches. So area equals 1.23 square inches. We're going to do the same thing with the brake caliper and the wheel cylinder, right? So brake caliper, piston area is next. Formula doesn't change. Pi r square. Of course, we need a radius. So we'll go 3.25 divided by 2. It's going to give us 1.625. So if I plug that into my formula, we're going to go 3.14 times 1.625 times 1.625. So 3.14 times 1.625 times 1.625 equals 8.291565, so we're going to call that 8.29 square inches. And we'll just throw that up here. Do the same thing for the wheel cylinder. We need a radius. This time I can do it without a calculator. Same formula. Area equals pi r squared. So we're going to have 3.14 times 0.25 times 0.25. .14 times 0.25 times 0.25 is going to give us 0.196, so I'm going to round this to 0.20. So we got a reference now. We can move on to our questions. We can work through the side of the sheet. Now that we've got our reference here, we can go ahead and start on our questions. So the first one on the imperial side of the sheet is this guy right here. And it asks, if the driver presses on the brake pedal with 250 pounds force, what will the resulting hydraulic system pressure be? So we know that the driver himself is pressing on the end of the pedal with 250 pounds force, and we're looking for a hydraulic pressure. So there's a couple of things we have to do here. First of all, if we're looking for a pressure, right, using Pascal's law, what we need to do is we need to take the force and we need to divide it by an area, right? We have to figure out which force in which area. We're talking about the driver pressing on the pedal, so we're going to be looking for an input force, right? And we're looking for the hydraulic system pressure, so the pressure in the entire system. That's created by the master cylinder, right? So we're going to be looking for the input force on the primary piston of the master cylinder, and we are going to divide that by the area of the master cylinder piston. Now, we already know the area of the master cylinder piston because we did the math already, right? So it's 1.23 square inches. So we've got that. And the force, it appears that we have that already, but we have to remember that this is going to be multiplied through the pedal. So the first thing we need to do here, if we break this down by steps, which of course we will, and I'm just going to keep the question kind of up here where we can see it, and we'll bring that reference chart back in as we need it. So this is question number 1 on the imperial side. The first thing we're going to do, we'll call this step 1, is we need to calculate the output force of the brake pedal. And I'm just going to put in brackets here. This is going to be the input force for the master cylinder. Right? Because the output is going to be the push rod. The push rod is going to act on the primary piston of the master cylinder. So we know that the driver is inputting 250 pounds, and we calculated a mechanical advantage of 2.53 to 1. So I'm going to say output force equals input force times mechanical advantage. So output force equals input force, 250 pounds, multiplied by our mechanical advantage of 2.53. $250 times 2.53, 632.5 pounds. So that's the output force of the brake pedal assembly and the input force that's going to be acting on the primary piston of the master cylinder to create the pressure. Now step 2 is going to answer the question. We're going to calculate hydraulic system pressure. Right? And we know for pressure, like we said, cover up the P. What we got left is force divided by area. So we're looking for a pressure. We're going to go P equals force divided by area. P equals the force that we just calculated, 632.5. And we're going to divide that by the area of our master cylinder piston, which we calculated at 1.23 square inches. So, that number's already there, but 632.5 divided by 1.23 is going to give us a hydraulic system pressure of 514 point, let's call that 23 psi. And that's the final answer for that question, right? So we've got the amount of force the driver is applying to the pedal multiplied by the mechanical advantage of the pedal to get the input force of the master cylinder. We take that force, we divide it or spread it out over the area of the piston that's creating the pressure. That gives us our system pressure of 514.23 pounds per square inch, which means there's 514.23 pounds acting on every square inch of the hydraulic system from the inside, right? Undiminished and at right angles on equal areas. For question number 2, it says, using the hydraulic system pressure from the previous question, calculate the output force of the brake caliper piston. Well, like it says, we've already calculated this. So we've got the number we need there. And we've also calculated the area of the brake caliper piston at 8.29 square inches. So this should actually be pretty easy and quick. So let's have a look here. For 2, as far as steps, because we're looking for a force and we already have the numbers that we're looking for, or the numbers that we're going to use for the formula, we've really only got one step here. So what we're going to do is we're going to calculate output force. Let's call it calculate caliper piston output force. Now, we're looking for a force, right? Which means we cover up dF. It's going to be a pressure multiplied by an area because they're side by side, right? So we're going to say force equals pressure times area. Force equals pressure. Well, we just calculated the pressure. It's going to be 514.23 multiplied by the area of the piston. .29 square inches. Which is going to give us a force .514.23 multiplied by 8.29. 4,262.96 pounds. Right? 966, let's call that 97. So we'll say 4,262.97 pounds. Okay, output force at the actual caliper. So what are we doing here? Well, we generated this pressure, the system pressure, right? In our first question, we know that 514.23 psi literally means 514.23 pounds acting on every square inch of the system. And we know because we calculated it to be our output piston has an area of 8.29 square inches. So we multiply this by this, and that gives us the output force of the caliper. Okay, and that's the final answer for question number 2. For question 3, it says if the driver reduced the amount of force applied to the pedal to 56 pounds, what would the output force of each wheel cylinder piston be? So we got a few steps here because we got some stuff that we're going to have to figure out. So we go question 3. What we're looking for as the end result is the output force of each wheel cylinder piston, right? So in order to get force, we need a pressure and an area. We've done all of our area calculations, so we've got that, but we don't know what the pressure is, right? So we're going to have to calculate the pressure. And of course, to calculate the pressure, we're going to need a force and an area. Again, we've got area covered, but we're going to have to figure out the force. So step 1 in this case, if we kind of work backwards through it like that, we're going to have to calculate the new brake pedal output. So we're going to say output force equals input force times mechanical advantage. Same car, same pedal, that's not going to change. So output force equals our new input force, which is 56 pounds, multiplied by our mechanical advantage, which if we bring our chart back, is 2.53 to 1. So 56 pounds multiplied by our mechanical advantage of 2.53 is going to give us an output force of 141.68 pounds. Okay, so that's step one complete. Now the next thing we're going to need is to figure out the pressure, right? Because again, we're looking for a force, and to find that force, we're going to need a pressure in an area. So the next thing we're going to need, because we already have the pressure, is going to be because we already have the area, is the system pressure, so that we know how much pressure we can apply to the area to get the final output. So step two, we're going to calculate hydraulic system pressure. Right? And we know that pressure is force divided by area. And so pressure equals force, which is our master cylinder input force, which we just calculated, divided by the area of the master cylinder piston, because we're looking for the system pressure. So we've already calculated that, 1.23 square inches. So we're going to go 141.68 divided by 1.23. $141.68 divided by 1.23 gives us a system pressure of, let's call this 115.19 psi. And that's step two complete. So now that we know how much system is acting on every square inch, or how much pressure is acting on every square inch of the hydraulic system, we can take that and we can look at our output, which in this case are the wheel cylinder pistons, and we've already calculated the area of that. Right? So we're looking for a force. It's going to be a pressure times an area. We just calculated the pressure. We already had the area. Right? So step three here, I'm going to get the question out of the way from that. We're going to calculate wheel cylinder piston output force. Right? It's a force, which is pressure times area. Well, pressure is 115.19. Multiplied by my wheel cylinder piston area of 0.2 square inches. Let's put the answer down here. Force equals 115.19 times 0.2, 23, we'll call that 23.04. So 23.04 pounds, that's the output at each wheel cylinder piston. And that's what we were looking for here, was each wheel cylinder piston. If it asked for the total output force of the wheel cylinder, we would have to multiply this by 2 because obviously there's 2 pistons in there. But in this case, we were only looking for a single piston's output force. Okay, so there's your final answer for that question. Moving on to question 4. It says if the hydraulic system pressure is 785 psi, what is the input force acting on the master cylinder piston? So this is a fairly easy one. One step only. All we're looking for is the input force. So we're looking for a force that's going to be a pressure times an area. Right? And in this case, they've given us the pressure, right? So we don't have to do any calculations to find that. And the area is going to be the area of the master cylinder piston, which we've already calculated. So the one thing to remember here is a force is a force. Okay, so it doesn't matter if the force is an input force or an output force. That force is calculated the same way. It's just a force. We're going to take the pressure, we're going to multiply it by the area. Right? So in this case, force is pressure times area. Pressure is 785 psi multiplied by the area of the master cylinder piston, which is 1.23. So our force, 785 times 1.23 is going to give us 965.55 pounds of input force. And just to prove that out, right, because sometimes people tend to want to overcomplicate this, right, when they're looking at an input force or an output force. But like I said, it's totally the same. If we turn that around and we look for the pressure, right, so the pressure would be the force divided by the area. Right, so P equals force divided by area. P equals the force, 965.55, divided by the area, which is 1.23. .55 divided by 1.23 equals 785, right? Which is what we had for a system pressure. So it's the same thing. Put that in its own box so that I don't get confused here. As far as the imperial side of the worksheet goes, we've only got one question left, number 5. And it says, based on the force calculated in the previous question, how much force is the driver applying to the brake pedal? So we know how much force is being applied to the master cylinder. We know that this force would be a result of the driver's input multiplied by the mechanical advantage. So if we want to work backwards, all we're going to do is divide. Right, so number 5 here, give this an area. What we're doing here is calculating pedal input force. And I'm just going to put in brackets here driver's foot. And the pedal input force is going to equal pedal output divided by mechanical advantage, right? If we want to know the output, we take the driver's input and we multiply it by the mechanical advantage. So if we want to know what the driver's putting in, we take the output and we divide it by the mechanical advantage. I'm just going to slide this up here. Right? So we're going to say pedal input force equals 965.55 divided by our mechanical advantage, 2.53 to 1. Which gives us 965.55 divided by 2.53. And we get 381 point, we'll call that 0.64. So the pedal input force equals 381 pounds, well, 381.64 pounds. And that finishes out the imperial side of the worksheet. So now we're on the metric side of the worksheet, and you'll notice that it's pretty much a mirror image of the first. The numbers are different, the units are different, but what we're looking for and how we're going to get it, nothing really changes there. So we're going to do the same thing we did with the last one because we have our specifications. Only difference now is they're in centimeters rather than inches, right? Because we're in metric. Similarly, our force is going to come in kilograms rather than pounds, and our pressure is going to be expressed in kilograms per square centimeter rather than pounds per square inch. Right? But the way that we go about calculating all the different values that we need, nothing's going to change there. So again, we've got our pedal to fulcrum. This is going to be our input or our effort. We've got our output to fulcrum. That's going to be our load arm. And if we calculate our mechanical advantage, which of course we will, mechanical advantage, of course, is effort over load, or EA over LA. Right, 27 divided by 7.5. So 27 divided by 7.5 gives us a mechanical advantage of 3.6 to 1. And we'll just throw that on our little chart here for reference. Then again, we've got diameters, we need areas, right? So we're going to take our diameter, divide it by 2, equals radius. Right, so our first diameter there, this is for the master cylinder piston, is 2.25 divided by 2, which gives us a radius of 1.125. Once we have that, we can calculate our area. Right, so we'll go master cylinder piston area. A is pi r squared, 3.14 multiplied by 1.125 times 1.125 again, 3.14 times 1.125 times 1.125 gives us, let's call that 3.97. And in this case, it's going to be square centimeters. Right. Throw that in here. A equals 3.97. We move down to the caliper piston, we can do the same thing. Right? We're going to divide that by 2 to give us the radius. So 8.25 divided by 2 gives us a radius of 4.125. So caliper piston area. Formula is not going to change. And our radius was 4.125 times under 4 1/8. So 3.14 times 4.125 times 4.125 gives us 53, let's call that 53.43. Square centimeters. Throw that on here. 53.43. And then lastly, we got to calculate our wheel cylinder piston area. Of course, the same formula again. We got to divide that one by 2 to get the radius again. 1.75 divided by 2, 0.875. So 3.14 times 0.875 times 0.875. 3.14 times 0.875 times 0.875 equals, let's call that 2.4. And we'll throw that up here. We got our reference all filled out, and we're ready to move on. Okay, we're on to question 6. Now this is 6 on the overall worksheet. This is the first of the metric questions. And similar to question 1, it says if the driver presses on the brake pedal with 140 kilograms of force, what will the resulting hydraulic system pressure be? And then there's just a little kilograms per centimeter square here just to remind us that this is the unit that we're looking for, because we're looking for a pressure. So to find a pressure, we're going to take a force and we're going to divide it by an area. But the problem is we don't know what the force is, right? Just like in the first question. We know how hard the driver is pressing on the pedal, but we don't know what the output force of the pedal is. So the first thing we're going to do here, step 1, we're going to calculate brake pedal output force. Which is also, again in brackets, the master cylinder input force. Right? So we're going to say output force, pedal output force. Equals driver's input. Or input force, we'll say. Times mechanical advantage. So we'll go output force equals input force, which was 140 kilograms, multiplied by our mechanical advantage, which in this case is 3.6 to 1. So our output force, output of the pedal assembly, input to the master cylinder, is 140 kilograms multiplied by 3.6 to get 504 kilograms. Right, it's force we're talking about. Okay, there's step one. Now that we have a force and we have an area, we can calculate the pressure, which is what we're actually after. So step two here, we're going to calculate hydraulic system pressure. Okay. We know, once again, pressure is going to be a force divided by an area. So P equals force divided by area. Our force we just calculated at 504 divided by, because we're looking for the entire system's pressure, we're looking at the master cylinder piston area, right, which we calculated at 3.97. Therefore, our system pressure is going to be 504 divided by 3.97. We're going to get 126.95, we'll call that. Kilograms per square centimeter. Right? That's our final answer for, of course, the first question there. That's our system pressure. The pressure here is exactly the same as the pressure in imperial. In imperial, we had pounds per square inch, right? So X number of pounds working on every square inch of the system. In this case, we're kilograms per centimeter square. So with this system, we've got 126.95 kilograms acting on every square centimeter rather than every square inch. But the principle is the same. Next, we're looking at question number 7. Second question in our metric side. It says, using the hydraulic system pressure from the previous question, calculate the output force of the brake caliper piston. So we've done this before. We're looking for a force, so we need a pressure and we need an area. There's only one step here because we just calculated the pressure, so we have that. And from our reference chart that we did before the first question, we know what the area of the brake caliper piston is going to be. So this is question 7. And all we're doing is calculating brake piston output force. Right? So it's a force, which is a pressure times an area. Pressure we already calculated, 126.95. Multiplied by an area we've already calculated. Right? 53.43 square centimeters. That's going to give us an output force at the caliper of 126.95 multiplied by 53.43 to give us 6,782. Let's call that 94 kilograms. 6,782.94 kilograms. That's the final answer for number 7. We don't have to do anything else there. On to question 8. This is another multi-step one. If the driver reduced the amount of force applied to the pedal to 67 kilograms, what would the output force of each wheel cylinder piston be? So we've seen this before, right? So we're going to have to do a few things. Again, the end game here is to find a force, right, which is going to be a pressure times an area, but we don't know what the pressure is. The pressure is going to be a force divided by an area. We know the area, but we don't know the force of input, or input to the master cylinder, which would be the output force for the pedal assembly. So we're going to have to calculate that first. Right? So step one, calculate brake pedal output. Which is, again, master cylinder input. Same thing, right? So, brake pedal output force equals drivers, or input force. We'll call it pedal input force. How hard is the driver pushing on the pedal, multiplied by the mechanical advantage. Right, so we'll go, I think I keep changing my acronyms every time I do this, but whatever. Brake pedal output force equals the input, which was 67 kilograms, multiplied by the mechanical advantage, which we calculated at 3.6 to 1. This is going to give us a brake pedal output force of 67 times 3.6, 241.2 kilograms. That's what we need for step one. Step two, we're going to have to calculate the system pressure. Right, and that's a pressure. So it's a force divided by an area. Well, we know what the force is now. So P equals force divided by area, which is 241 kilograms, well, 241.2, divided by system pressure, needs to be the master cylinder area, right, which we calculated already at 3.97. So the system pressure is 241.2 divided by 3.97. It'll be 60, let's call that 60.76. Kilograms per square centimeter. Okay. Step two is now complete. Now, the third step is what's going to solve the question, and we're looking for an output force, right? So we need a pressure times an area. Now we have a pressure. We've already calculated the area. So step three, final step. We're going to calculate wheel cylinder piston output force. Okay. So it's a force, which is a pressure, times an area. We know the pressure because we just calculated it, so it's going to be 0.76 multiplied by the area. And we're looking for wheel cylinder this time, right? So 2.4. So our output force for our wheel cylinders are 60.76 times 2.4, 145.82. Kilograms. Right? And again, that's per piston. Right, so multiply that by 2 for your total wheel cylinder output. All right, question number 9. If the hydraulic system pressure is 45 kilograms per centimeter square, what's the input force acting on the master cylinder? I moved my page up a little bit, so I'm just going to put our triangle over here. This is number 9. I keep forgetting the number of the questions. Right? We're looking for force again. So once again, pressure times area. Right? So force equals pressure times area. They've given us the pressure. And we're looking for the area of the master cylinder, which we've already calculated at 3.97. So our input force, 45 times 3.97. We got 178.65 kilograms of input force. And for that question, that's all we got to do. Remember, it doesn't matter if it's an input force or an output force, a force is a force. It's always going to be pressure times an area. All right, so our last question here, number 10. Based on the force calculated in the previous question, how much force is the driver applying to the brake pedal? So this is number 10. And what we're doing here is calculating pedal input force on the driver. Right. So to find pedal input force, we're going to take the pedal output force and we're going to divide it by our mechanical advantage. So the force that we had in the last question, I'm on a clean piece of paper now, but I'm just going to make a note at the top, was 178.65. This is the pedal output from question 9. Right? So we're going to say pedal input force equals 178.65 divided by our mechanical advantage, which we calculated at 3.6. So the pedal input force, how much or how hard is the driver pushing on the pedal? 178.65 divided by 3.6, 49, we'll call that 49.63. Kilograms. And that's our final answer. So of course, if we were doing that the other way, we would have been given the 49.63. We would have multiplied it by the 3.6 to get the pedal assembly output, which would have been the input for the master cylinder. But in this question, again, we've done it the opposite way.